brand new window right here. I want to show you something. Sometimes you have, I'll draw this really quickly. You've got a graph that looks something like this, right? And they say, okay, well now I want you to estimate what a, let's say that this is a, let's just say this is a velocity, and this is time. So this would be in meters per second, and this would be in seconds, right? Now they say, okay, well now I want you to draw from this graph, I want you to draw an acceleration versus time graph. Well, how would you do that? You look and you'd see, all right, what's the slope right here? Well, the slope here is approximately, and you'd find out what the tangent line is right here. That would be at that point what the slope is. So let's just make up a number here because I don't have any numbers related to this. Let's just say that this slope right here, we determine what this tangent line is. We say, well that slope of that line right there, that is 20. And it would have to be meters per second. Okay? Per second. So that would mean that at that point, the acceleration is, whoa, it's way high. It's at 20. So we could say, okay, that's what that point is. That point right there is just 20. Then, let's say it goes a different point. Let's say it's at that point. You find out what the slope is of the line of this graph is at that point. Okay, it's right about there. Let's say that that is now 10 meters per second. So that's the slope at that point. So at that point right on down over here, that same time point, we'd say, okay, well now that acceleration is only as a 10. Okay, meters per second squared. Okay, at this point right here, let's make it right there. I meant to draw a horizontal line. At that point right there, that slope is 0. So that means at that same time point right here, the acceleration is 0. All right? Here, at this point right there, which corresponds to a point down here in time, there's a slope of this graph. Whatever that slope is, let's say that slope is, let's say it's like -5. So at that same point right here, it'll be -5. Okay, so all you're doing is you're finding slopes at various points in this graph. Okay, the slope right here is a little bit more steep, so it's going to be a little bit more negative. It'll be something like, I don't know what this is, but let's just say it's -10 just for simplicity. So that would mean at this point right down here in this graph, it would be down at -10. Okay, -10. So all you're doing is you're saying, okay, at this point, what is the slope? Well, then I can just report what that point is down over here. At this point, what is the slope? 0, so it's right there. Okay? So that's when you have a curved line and you want to find out what the slope is of that curved line throughout time. And funny enough, look at this. I made this nice and smooth, and I kind of estimated it like this. So it turns out to be almost like a straight line down here. But don't worry about how straight this line is. Just think about, okay, at this point, at that time point, what is the slope of this graph right here? And that's what you report. Just go point by point. That'll make it much simpler for you. Down over here, it looks like it's a flat line, so it's a horizontal line. So that would be then back at 0. So this would be 0 right there. Okay? I hope this makes a lot more sense now, and I hope this kind of helps you graph various slopes of other graphs. It's a hard concept. Don't get me wrong. It's not an easy concept to learn. Many students have difficulty with this throughout the whole year. It's a very visual thing to graph the change of something. But the more you practice it, the more it'll make sense. If you need extra websites to practice on this, I can try to find some more for you. Just email me, and I'll try to find some more. I hope this helped. Good luck. Bye.